This is first stream for today. This is day 4. So far we have covered the SQL, PostgreSQL and basics of Python. So as per the roadmap, so as per the now I was going through something and I got to know in Python fast API is a framework that we use to develop the
Post table.
This massive and comprehensive Python API course is taught by Sanjeev Thiagarajan. He is an excellent teacher and has taught many popular courses.
Hey, how's it going, everyone? I just wanted to welcome you to my Python API development course. So in this course, I'm going to walk you through building out your very own API in Python. However,
now before that, let's have a quick intro about this API right now.
REST is the most common communication standard between computers over the internet. What is it? Why is it so popular? Let's take a look. API stands for Application Programming Interface. It is a way for two computers to talk to each other. The common API standard used by most mobile and web applications to talk to the servers is called REST. It stands for Representational State Transfer. It is a mouthful. What does that mean? REST is not a specification. It is a loose set of rules that has been the common standard for building web APIs since the early 2000s. An API that follows the REST standard is called a REST loose mouthful. What does that mean? REST is not a specification. It is a loose set of rules that has been the common standard for building web APIs since the early 2000s. An API that follows the REST standard is called a RESTful API. Some real-life examples are Twilio, Stripe, and Google Maps. Let's look at the basics of REST. A RESTful API organizes resources into a set of unique URIs or Uniform Resource Identifiers. The URIs differentiate different types of resources on a server. Here are some examples. The resources should be grouped by noun and not verb. An API to get all products should be /products and not /get all products. A client interacts with a resource by making a request to the endpoint for the resource over HTTP. The request has a very specific format as shown here. The line contains the URI for the resource we'd like to access. The URI is preceded by an HTTP verb, which tells the server what we want to do with the resource. A POST request means we want to create a new resource. A GET means we want to read the data about an existing resource. A put is for updating an existing resource. A delete is for removing an existing resource. You might have heard the acronym CRUD. This is what it stands for. In the body of these requests, there could be an optional HTTP request body that contains a custom payload of data, usually encoded in JSON. The server receives the request, processes it, and formats the result into a response. The first line of the response contains the HTTP status code to tell the client what happened to the request. Now, a well-implemented RESTful API returns proper HTTP status codes. The 200-level codes mean the request was successful. The 400-level codes mean something was wrong with our request. For example, the request contained incorrect syntax. At the 500 level, it means something went wrong at the server level. For example, the service was unavailable. A well-behaved client could choose to retry a failed request with a 500 level status code. We said could choose to retry because some actions are not idempotent, and those require extra care when retrying. When an API is idempotent, making multiple identical requests has the same effect as making a single request. This is usually not the case for a post request to create a new resource. The response body is optional and could contain the data payload and is usually formatted in JSON. There's a critical attribute of REST that is worth discussing more. A REST implementation should be stateless. It means the two parties don't need to store any information about each other, and every request and response is independent from all others. This leads to web applications that are easy to scale and well-behaved. There are two final points to discuss to round out a well-behaved RESTful API. If an API endpoint returns a huge amount of data, use pagination. A common pagination scheme uses limit and offset as parameters. Here is an example. If they are not specified, the server should assume sensible default values. Lastly, versioning of an API is very important. Versioning allows an implementation to provide backward compatibility, so that if we introduce breaking changes from one version to another, consumers can get enough time to move to the next version. There are many ways to version an API. The most straightforward is to prefix the version before the resource on the URI. For instance, like this. RESTful API is simple and effective when applied sensibly. It may not be the best choice for all companies, but it is simple and good enough, and that's why it is so widely used. There are other popular API options like GraphQL and gRPC. We'll discuss those and compare them in separate videos. If you would like to learn more about system design, check out our books and weekly newsletter. Please subscribe if you learned something new. Thank you so much, and we'll see you next time.
Basic, I have kind of understanding.
Hello and welcome to Pseudocode. This video is a part of a mini series on APIs, or I would better say REST APIs. If you have not seen the first video on the REST APIs, then make sure to check it out. In this video, we are going to talk about some terms and taxonomy of represent possible. To interact my customers, it should list all the customers. So this is what a path parameter is and how a path parameter is used. Again, when we will talk about the implementation of path parameter and how it can be used in these resources. Second, how to represent these slash HTTP protocol using REST APIs. Now, what actually are REST UI or the client type request for this data? Now, this same data has to be transferred from one layer like server layer to the client layer, and it would be transferred in a JSON format, because that's what we do in most cases. In case of REST APIs, the data is transferred using JSON format. So this data is transferred in a JSON format, and UI may represent it in a different way. So for same resource, there are different representations, and that data or that resource is getting transferred from one layer to another. Now, when this customer record gets updated, then in that case, what happens is the resource state changes and its representational state will also change. So when a resource has been updated, now the representational state which was shared earlier is different from the representational state which will be shared now when the customer record has been updated. I have summarized here and in the links the difference between resource, representational state and representation. I hope it is clear to you guys. So REST APIs are all about managing these resources, creating and updating these resources. Second, how to represent these resources on different layers. And third point is about how to pass one representational state from one layer to another. Now, as I mentioned, this is done over HTTP protocol using these resources, creating and updating these resources. Second, how to represent these resources on different layers. And third point is about how to pass one representational state from one layer to another. Now, as I mentioned, this is done over HTTP protocol using REST APIs. Now, what actually are REST APIs? Any REST API implemented over HTTP protocol will be composed of a URI or Uniform Resource Identifier, which points to exactly some resource in your database. Let's say we call our app as My Store app. So HTTPS My Store app /customer/1. Now this URI is going to point to a resource in our system, which is this customer record. This URI is also known as API endpoint or path in some cases. Now there are different methods like get or post or put or patch, etc. to modify this resource or to interact with this resource. For example, using get might give you the information about this resource. Using put will update this resource. Using patch will also update this resource. Using delete will delete this resource. And using post, you might be able to create a new resource. We're going to cover the details of all these methods in detail in separate videos, but here I'm just trying to cover the basic terminology. So now that you understand what a URI is, let's try to understand change this resource customer/1 and I want to update the address with this.
However, keep in mind, this course is so much more than just building out a simple API. In fact, as I'm see, we get a 201, which means we were successfully able to create it. You can see the ID of the user account that was created. We can see it means we're SQL Alchemy. I decided to use that because that seems like that's the most standard one for Python. I really could have chosen any of them. I didn't really care which one I used, so I just picked the most popular one. So that covers our tech stack. I did it extensively, and you see this magnificent beast? This is the creator of the Fast API framework. And my mom always told me, when someone with a mustache is glory creator about databases or SQL in general. But by the time you complete this course, you will be very proficient at generating database schemas. You'll know core SQL concepts like primary keys, foreign keys, table constraints, and you can pretty much be able to generate SQL queries to grab the exact data that you're looking for. And on top of that, I'll show you how to integrate your SQL databases in your API using two different methods. So we'll cover both using raw SQL queries as well as ORMs, so that no matter which method you ultimately prefer, we'll also familiarize ourselves with database migration tools like Alembic, which allow us to make incremental changes to our database schema to track like Postman to construct HTTP packets so that we can test our API during the whole development process. And when it comes to testing, I've added about 2 to 3 hours of content going over how to set up automated integration tests so that when you make changes to your code, you can run these automated tests to verify that your code changes haven't broke any pre-existing functionality. And then after testing, I didn't just include one method of deployment, I've actually included 2 different deployment scenarios. The first scenario is probably the most common scenario, which is deploying our app onto like an Ubuntu machine that can be hosted on any cloud provider like AWS, GCP, Azure, or even DigitalOcean. And we'll cover things like how to set up Nginx to act as a reverse proxy. We'll configure, set up SSLs, and deploy and it'll shout changes to create. You don't need to sign up with a credit card, so that's why I included using GitHub Actions.
This course is very big. You have to make a project by 24th. This might be a very good head start. Very good head start. Yeah. Now, only thing is, as far as I know, this covers a lot of SQL also and Git. Like around 2 hours of this content is pure SQL, Postgres SQL. Then Jones and shit and all. Review and all is good, so come back here. So yeah, I'm not trying to do the whole of this thing in like 10 days for sure, but I got that. So in this roadmap that I'm following, I've covered Python, internet basics is done, Git is done, Postgres SQL is done. Next thing was learning about APIs. Now when I started researching about that, what are APIs and how to make it and all, I came across Fast API. Fast API, a framework that you use, and once I started like researching about that, I came across this video. So if you have to see, let's analyze that what can see at the end of the day, I'll want to learn coding properly to be able to make projects. Okay, that's the goal. I'm not learning frameworks and all, right? So and Fast API is a better version of Django. Oh yeah, Flask API. Should we watch this also? This is how long this 4 months back.
Flask, Django, or Fast API? This is the question you should be asking yourself if you're interested in Python web development. In this video, I'm going to break down everything you need to know about these 3 different frameworks and tell you which one you should pick depending on your pick from, but if you really want to get to your use case. However, if you are going to build out a project using one of these frameworks, you're probably going to want to be utilizing an IDE. And not just because IDEs can make your life so much easier, but because experience whether you're working in Python, Go, Rust, Java, you name it, JetBrains has a fully featured professional IDE for you. These IDEs offer the best performance and speed and have impressive, not to mention features JetBrains of learning. Now there's not a lot of immediate difficulty. There are more concepts that you need to learn, you need to understand really. That means just, so now we can get into performance, starting with Flask. Frameworks here is by far the fastest, it's superior to all of them, and the reason for that is it's built asynchronously, meaning it can scale and it can handle multiple requests at the exact same time. Lastly, we move on to Django. Now, Django is the slowest of the 3 frameworks due to its comprehensive nature. However, it is still very reliable for large applications, and a lot of huge companies still use Django despite the fact that it's not the fastest out there. In summary, if you're really looking for the absolute best performance and you're building something like an API, then definitely choose Fast API, but for most of you, this isn't going to matter a ton, so simply pick the one that's easiest to use or best suited for your project. So now we're going to dive into the use cases, starting with Flask. Now, Flask for me is what I use when I want to build something really quickly and I don't want to deal with a ton of configuration or spend a lot of time setting up a server. If I need a really fast web server, if I want to get something done in just a few minutes, I'll definitely turn to Flask, and even for slightly larger hobby.
This will allow us to push out changes to GitHub, resulting in our pipeline running, which will pull our code, run all of our integration tests, build all of the necessary images, and if all the tests ultimately pass, it'll actually push out our changes to our production environment so that we can do all of this in an automated fashion without having to manually go in and run each step manually. So let's take a look at our tech stack. Since this is a Python API course, we will be using Python to build out our API. There were a couple of different web frameworks in Python that we could have used, most notably Django and Flask. I decided to use neither one of them, and I decided to use a newer framework called Fast API. And the reason why I chose to use this framework was because it has APIs kind of built in mind, right? It wasn't there to address like the model view controller type scenario. It really is all about building out APIs. And on top of that, it is really fast, right? But when I say fast, it's not just fast from a performance perspective, which it is, but it's also fast from the fact that it makes it really easy and quick to spin up new APIs. And one of my favorite features of this framework is the auto documentation functionality. When you build an API, you have to document how your API works. And this is a very cumbersome task because anytime you make any changes to your API, you have to remember to update your API, or then the front end could be making the wrong request. Fast API automatically documents your API for you so that you don't have to do it yourself. It's truly a game changer. And finally, the most important reason why I chose Fast API is because of this. You see this for Python, I really could have chosen any of them. Very cool extensive work. And my mom always told me, when someone with a mustache as glorious as that creates a web framework, you use that damn framework. Now, as I mentioned, we will be covering SQL extensively, and I've decided to go with Postgres. It doesn't really matter what type of SQL database you use. They're all fundamentally the same with only minor differences. I chose Postgres because that's my favorite, and who doesn't like elephants anyways? For our ORM, when we do eventually migrate to ORMs from using raw SQL queries, we will be using SQL Alchemy. I decided to use that because that seems like that's the most standard one for Python. I really could have chosen any of them. I didn't really care which one I used, so I just picked the most popular one. So that covers our tech stack. Let's now take a look at the project that we'll be building. Now, I would love to show you some cool flashy website that you can show off to your friends. However, we're not building a website, we're building an API. And unfortunately, APIs don't really have a visual aspect to them. So I don't really have anything to show you. I mean, I could, I guess, construct a couple of HTTP packets and send it and verify that we get the proper JSON response, but that's not really exciting. So what I'm going to do is I'm going to show you our documentation for our project so that you can see all the different features that we implement. And the nice part about the documentation is these are interactive docs. So from the documentation, I can actually send HTTP requests to my application and get a response back. So you can really see all of the different features, things like the authentication and the CRUD operations that we'll be performing and setting up in our API. So the app that we're going to build for this course is going to be a social media type application where users can create posts, they can read other people's posts, they'll be able to perform all of the CRUD operations, so they'll be able to create, read, update, and delete posts. And we'll also be able to vote on posts. So, most social media apps have some sort of like system or vote systems that retrieving all this information, got specific post that you actually any to our API with the built-in documentation. So you can just say execute, right? And you'll see that we got a 401, which means that let's actually go ahead and create a user. And so we'll go down to the user's endpoint under create.com. Is that right? So it'll get a couple of different ways to see that we have provided. I can go to the login endpoint, or we can just go up here at the top and just do authorize. And then we can provide that information. So I'll do john@gmail.com. Use what it is. So users and we'll try to retrieve an endpoint. So things like creating a user, getting a user's information. And then we've got our authentication, which is going to be used for logging in. And then finally, we've got the one for voting. So when you want to vote on a specific post that you like, you can go ahead and like that post. So let's just use the documentation to actually, test out our API. So first things first, let's actually try to retrieve any or all of our posts. So if I hit this get button right here, we can actually try to send a request to our API with the built-in documentation. So you can just say execute, right? And you'll see that we got a 401, which means that we are right now not logged in, so we are unauthorized to retrieve any of the posts. So the API that we're going to build is going to require all users to be logged in to even be able to read the posts. So let's actually go ahead and create a user. And so we'll go down to the user's endpoint under create user, and I'm going to do try it out. And it's going to give us an example of the structure of the data that we have to send to our API to create a user. So we need to provide a username or an email and a password. So I'm going to create an email. I'll call this john@gmail.com. And the password is going to be something simple, just for demonstration purposes. And we'll execute that, right? So it'll actually send that data back to our backend. You can see we get a 201, which means we were successfully able to create it. You can see the ID of the user account that was created. We can see the email is what it is, and then we can see the date that it was created at as well. And so now we can actually log in as this user. So there's a couple of different ways to log in. I can go to the login endpoint, or we can just go up here at the top and just do authorize. And then we can provide that information. So I'll do john@gmail.com, and we'll provide his password. And if we do authorize now, we can see that we have successfully logged in. So I'll close this out. And so now if I try to retrieve the posts and then hit execute, you can see that we were able to retrieve all of the posts in our database. Right now there's only 2, but you can see that these were created by some other users like Sanjeev in this case, and then Sanjeev123. And if we want to create our own post, we can go ahead and do that. So I'll go to the create post endpoint, and we'll do try it out. And it's going to give us an example here. So we have to provide title, content, as well as is this post going to be published or is it going to be a draft? And you'll actually see the structure of this schema right down here. I think it's at the bottom actually. So if you go to post, create here, this is going to show us the schema that we have to pass. So we have to provide a title, content. So the asterisk means it's required. The published is not required, and you can see that it defaults to true. So if we don't provide a value, it'll default to true. So let's test that out. And so I'll just say favorite foods is going to be the title, and the content is going to be pizza and burgers. And I will remove the published section because it is optional and it'll default to true anyways. And we'll hit execute. And if we take a look at the response, we get a 201, which means it successfully created it. And you can see what the post looks like in our database. You've got the title, content. We can see the published got defaulted to true. We can see the ID of the post when it was created. We can see the owner ID, which is, who created the post. And so that's the ID of our account, which is 17. And we can see the information about the owner. So this is john@gmail.com. And then, as usual, we can perform all the other CRUD operations. So we can retrieve an individual post, update it, and delete it. And then once again, if we go down here, we can also vote to like a post as well. And so, this kind of forms the backbone of a traditional social media type application. So once you can really do this, you can really create any application you want. And I think this covers enough things from an API perspective as well as from a SQL and database perspective that you will have a solid foundation to really build out any API that you're interested in building out. And so I think that's enough talking. Let's get to actually start coding out our application. In this video, we'll take a look at how to set up Python as well as VS Code on a Mac machine. So the first thing we're going to do is we're going to just search for Python Fast API, which is the name of the library, as this terminal right here. It's no different, but well, it's this. And then select this one to get back to your main file browser. And right now we haven't opened up any folder. So what we want to do is we want to create a folder to store all of our application code. So select open folder and then figure out where you want to store your application code. So I'm just going to store this in my documents. You can store this wherever you want. I'm going to create a new file or a new folder. I'm just going to call it Fast API, but you can name your project whatever you want. So just select folder. And so that's going to not only create the folder, but it's going to open it up within VS Code. If you get this error, just select trust the author and just select yes. And then we can close out this welcome menu. And so now what we have is we've opened up VS Code, and within VS Code we've opened up our project code. So right now there's no code, that's to be expected. But what I want to do is I want to create a new file real quick, just for testing purposes. So I'm just going to right click, hit new file. And we're going to name it main.py. And so we want to name it .py because this is going to be a Python file. And before I hit enter, I want you to focus your eyes right down here, and you'll notice something happens down there. So when I hit enter, you'll see activating extension. So it's activating the Python extension. And what the Python extension is going to do is it's automatically going to select the correct Python interpreter, or it may not be correct depending on what happens on your machine. For me, it automatically detected Python 3.9.6 was installed on this machine, so it selected that one for me. Keep in mind, if you have multiple versions of Python installed, it may select the wrong interpreter. So what you can do is if you ever want to change the interpreter or specify a specific interpreter, go to View, Command Palette, and what I want you to do is search for Python interpreter, and then look for Python select interpreter. So right now, it's going to highlight where the current Python interpreter is, which one selected, and what's the executable for it. But if you want to change that, you can select enter interpreter path and then provide the path to the specific version that you want. So you can obviously change it, but usually it's able to detect the latest version, so you should be good to go. And so that's all I wanted to do from a setup perspective. There's one more thing that we'll cover later, but we'll get to that in the next section. But right now we've got Python installed and we've got VS Code set up and we've got our project directory set up, so we should be good to go. So now that we have Python and VS Code set up, the next thing that we have to do is set up our virtual environment. Before we do that, we have to actually talk about what are virtual environments and what problem do they try to address. So let me give you a little bit of an example scenario of the issue that we can run into when working with specific packages within Python on your local machine. So let's say that we created a project, and this project is called Project 1. And what we need to do is we need to install Fast API version 1.2.1. So what do? We install version 1.2.1 on our machine so that we can actually use that version. Now let's say later down the road, we start a new project called Project 2. And let's say this version requires us to run Fast API version 2.4.3 because we want to try out some of the newer features. Well, at this point, if we need to try out a newer version, we have to upgrade Fast API to version 2.4.3 on our local machine. And this may or may not be a problem. It really just depends on if version 2.4.3 is backwards compatible with version 1.2.1. Because if version 2.4.3 has breaking changes, then ultimately that's going to create issues with our project 1 because that project expects us to run version 1.2.1. And so if we can't upgrade, well, we're in a little bit of a pickle because one project needs one version, the other project needs another version. We can't have two different versions installed on our machine. So what exactly do we do? Well, this is where virtual environments come into play. So with virtual environments, let's say we want to create a project. So we create project 1, and what we do is we create a virtual environment, call it whatever you want. And so this is a isolated environment that will not affect any other environments. And within this environment, we can install any Python packages running whatever version we want. And it's completely isolated to this project. And so when we create a second project, what we can do is we can create its very own virtual environment as well. We'll call it virtual environment 2. And within this virtual environment, we can install any version of any package that we want. So then we can install version 2.4.3. And so both of these virtual environments are completely separated, completely isolated with one another. And so we can essentially install multiple different versions of a single package for each of our projects. And that way our projects don't end up stepping on the toes of other projects. And so now that we have a basic understanding of virtual environments, let's go ahead and figure out how we can actually create our first virtual environment and use it within our project. In this video, I'm going to walk you through setting up a virtual environment on a Windows machine. Now, if you already closed out your VS Code window, go ahead and open up a new one and make sure you open open up the specific directory we created a couple lessons ago. Now what we want to do is we want to select terminal, and we want to select new terminal. And this is a awesome feature with VS Code. It allows us to have a integrated terminal within our VS Code window. And this terminal is fundamentally no different than a regular terminal within Windows. It's just built into VS Code so that we don't have to keep flipping between different windows. And if you actually take a look at this right column, we can have multiple terminals open, and we can even use different terminals. So the default one on this machine happens to be PowerShell, but you can also use command prompt if that's what you prefer. So if you select command prompt, it's going to create a new terminal, and you can see that this is a traditional command prompt. So I'm going to use this one because that's the one I normally use. However, if you're more comfortable with PowerShell, feel free to use that. Now the command to actually create a virtual environment within Windows is py-3 -m VNV, so that stands for virtual environment, and then you want to give it a name. So give whatever name you want for your virtual environment. You could name it after your project name, or you could just do what I do, which is just call it VNV. And what I like to do is for all of my projects, I give it the same exact name. And that's perfectly okay because this virtual environment is going to be isolated to this project directory. And so even though this project has a virtual environment named VNV, I can create another virtual environment in any other project with the same exact name. And they're all going to be isolated to that specific project folder. So go ahead and hit enter. And take a look over here. You'll see that a folder was created called virtual environment, or VNV. And that's going to be, the name of this folder is always going to refer to do whatever name you gave it. So if I named this cookies, this would open up a new folder called cookies. And if you want, you can take a look at what's in here. And if you go under scripts specifically, you'll notice that we've got our Python executable. So this is going to act as our new interpreter. And so what we want to do is right now we are using our global interpreter, and we want to change that. We don't want to use the global one. We want to use the specific one in our virtual environment. And that way we can install packages that are exclusive to just this specific virtual environment. And so to do that, go ahead and select View once again. And we want to go to Command Palette. And then search for Python Select Interpreter, as usual. And then you'll see the one we're currently using, but we want to pass in our newest one. So select Enter Interpreter Path, and then we want to give it the path to our interpreter, which is the path from the root of our project directory to this python.exe file. So we're going to say dot, which is our current folder. So this is going to be the fast API folder. And then within here, we want to go into scripts. And then within scripts, we want to go into the virtual env folder, then scripts, and then python.exe. Go ahead and hit enter. And then if you look down here, you'll see that this gets updated. So now we're still using 3.9.6, but we're using our virtual environment. And so that's all we need to do, and it should remember this every time we open up our project. However, double check every time you open up just to make sure you're using that. If it's for some reason moved back to the default one, just do the same process. Now, the second thing that we need to do is we need to make sure our terminal is also using the virtual environment. And so what we want to do that is just type in the path to this specific activate.bat file. So this is going to activate that virtual environment within our command line as well. So I'm going to say virtual env, and then we want to pass in our our scripts folder, and then activate.bat. Hit enter, and then notice what's changed, right? So when you're using a virtual environment, right, you're going to see the name of the virtual environment to the side of it. So always double check whenever you start up VS Code and you start up your project that this is enabled. If you don't see this, then just run this same exact command, and that's going to reactivate the virtual environment. And so at this point, we are good to go with our virtual environment, and we can start coding out our project. In this video, I'm going to walk you through setting up a virtual environment on a Mac machine. Now, if you've already closed out your VS Code window, go ahead and open it back up and open up the folder that we created a couple lessons ago. Now within here, what we want to do is we want to access our terminal. So we can access our terminal just by selecting this, and then this is our terminal. However, VS Code has a feature where we can access the terminal directly within our VS Code window. So terminal in fourth, so you don't have to move there. If you want to see the same thing, here what we want to do is we want to access that. Whenever you start this video, I'm going to walk you through setting up a virtual environment on a Mac machine that we create right here. It's no different, but at least by having it built into VS Code, we don't have to keep flipping the folder machine into VAP. Mac create is the same. If we thought that our environment, we are using the global one. However, we're going to like cause any issues with other projects. We want to use the virtual environment. So to do that, what we want to do is we want to select a view, command palette. However, we're going to pass in the path to our specific interpreter within our virtual environment. So we'll select enter interpreter path. We'll say dot for current directory. And so that's going to mean the current fast API directory. Then within there, we want to go into the virtual environment folder. And then within there, we want to go into bin and then just say Python. And so we'll hit enter and then take a look at what happens down here. Right, you notice that the version still says 3.9.6, but our interpreter is actually pointing to our local virtual environment now because we changed the interpreter to use this specific Python file right here. And so this is what's going to allow us to install our own again. So we'll select that. Right, and so right now it shows us that we are using the global one. However, we're going to pass in the path to our specific interpreter within our virtual environment. So we'll select enter interpreter path. We'll say dot for current directory. And so that's going to mean the current fast API directory. Then within there, we want to go into the virtual environment folder. And then within there, we want to go into bin and then just say Python. And so we'll hit enter and then take a look at what happens down here. Right, you notice that the version still says 3.9.6, but our interpreter is actually pointing, right? It's and then just say Python. And so we'll hit enter and then take a look at what happens down here. Right, you notice that the version still says 3.9.6, but our interpreter is actually pointing to our local virtual environment now because we changed the interpreter to use this specific Python file right here. And so this is what's going to allow us to install our own specific fast API version, as well as any other version of any package that we want, so it doesn't actually install it globally on our machine. Now we're almost done, but there's one other thing to note. If you look at our terminal isn't using our virtual environment. So if I run pip install any package, it's not going to install it for our specific virtual environment, it's going to install it globally. So we have to enable the virtual environment for the command line path by the name of our virtual in your virtual environment. Still by going to view command palette and then our virtual environment set up. And so at this point, we can go ahead and get started on coding out our project. And what I want you guys to do is, first of all, go to the Fast API documentation. This is really important. What I want you guys to do is really get a solid understanding of how the documentation works. So pull up the Fast API website and then head on over to the tutorial section and then select the intro part. So this is going to walk us through setting up our project. And what we will need to do is, first of all, we need to install the Fast API package. And so what we can do is we can either do pip install Fast API, or we can do pip install Fast API all. When we do pip install Fast API all, it's going to install all of the optional dependencies as well, which we may or may not need depending on what features we want. We're going to go ahead and use the all option because we're going to use a lot of them, and there's no point in having to go one by one and install them. So that's what we're going to do. So here in our command line, and make sure that we are in our virtual environment, and then just type in pip install Fast API, and then we'll pass in all, and we'll let that run. Now it's moving fairly fast, but if you kind of scroll through the history, you'll notice a lot of packages and a lot of dependencies that are getting installed. So we'll take a look at those once it's done, just to see what are the different dependencies that were installed. And so now that that's done, if we type in pip freeze, this is going to show all of the packages that were installed. So it's not going to be just Fast API, it's going to include a lot of the optional dependencies as well. So if we take a look, you can see that we've got GraphQL installed if we want to use any GraphQL. We have bcrypt, UVcorn, that's going to be like our web server, WebSockets if we want to work with WebSockets. So it already comes bundled with a lot of things that we're going to use. And I just wanted to make sure that you guys understood what's happening when we pass in that all flag. And if you want to, if you open up your virtual environment folder and you go under lib, you'll see all of the code associated with those packages that we installed. So that's where all of them are going to reside. They're all going to reside within the lib folder. All right, so now that we've got Fast API installed, the first thing that we have to do is we have to import Fast API. And to import Fast API, we just say from Fast API, which is the name of the library. We import Fast API. All right, so we've now successfully imported Fast API. Let's create an instance of Fast API. So we'll say app equals Fast API, and then we'll call that function. Keep in mind, you can name this anything you want, but if you take a look at the documentation and just follow along, you can see that it's going to name an app. So I think it's best if we just kind of follow along with that convention. Then what we're going to do is we're going to take one at importer at all flag. For all dependencies, look update. We can either do that you specifically want. But that's all we have to do, guys. So our virtual environment's set up, and so at this point we can go ahead and get started on coding out our project. So now that we got our environment set up, it's time to get started coding out our project. And what I want you guys to do is, first of all, go to the Fast API documentation. This is really important. What I want you guys to do is really get a solid understanding of how the documentation works. So pull up the Fast API website and then head on over to the tutorial section and then select the intro part. So this is going to walk us through setting up our project. And what we will need to do is, first of all, we need to install the Fast API package. And so what we can do is we can either do pip install Fast API, or we can do pip install fast API all. When we do pip install fast API all, it's going to install all of the optional dependencies as well, which we may or may not need depending on what features we want. We're going to go ahead and use the all option because we're going to use a lot of them, and there's no point in having to go one by one and install them. So that's what we're going to do. So here in our command line, and make sure that we are in our virtual environment, and then just type in pip install fast API, and then we'll pass in all, and we'll let that run. Now it's moving fairly fast, but if you kind of scroll through the history, you'll notice a lot of packages and a lot of dependencies that are getting installed. So we'll take a look at those once it's done, just to see what are the different dependencies that were installed. And so now that that's done, if we type in pip freeze, this is going to show all of the packages that were installed. So it's not going to be just fast API, it's going to include a lot of the optional dependencies as well. So if we take a look, you can see that we've got GraphQL installed if we want to use any GraphQL. We have bcrypt, UVcoin, that's going to be like our web server, WebSockets if we want to work with WebSockets. So it already comes bundled with a lot of things that we're going to use. And I just wanted to make sure that you guys understood what's happening when we pass in that all flag. And if you want to, if you open up your virtual environment folder and you go under lib, you'll see all of the code associated with those packages that we installed. So that's where all of them are going to reside. They're all going to reside within the lib folder. All right, so now that we've got Fast API installed, the first thing that we have to do is we have to import Fast API. And to import Fast API, we just say from Fast API, which is the name of the library. We import Fast API. All right, so we've now successfully imported Fast API. Let's create an instance of Fast API. So we'll say app equals Fast API, and then we'll call that function. Keep in mind, you can name this anything you want, but if you take a look at the documentation and just follow along, you can see that it's going to name it app. So I think it's best if we just kind of follow along with that convention. Then what we're going to do is we're going to just copy this code right here. So this is going to be what's referred to as a path operation, and we'll go over what that means in a bit. And we'll just paste this here. I want you to save your code. You'll see if you get this warning or this message saying formatter autopep 8 is not installed, go ahead and hit yes. And so this is nice because it'll automatically format our code. So if we ever put too many spaces or things like that, you'll see that as soon as you save it, it's going to snap into place and make everything look nice and pretty. So let's save this. And so once we've got our code, let's actually start our web server up. So how do we actually start our web server? Well, once again, let's go to our documentation. So we're going to make use of the UVcoin library. So because we installed Fast API with the all flag, it automatically installed UVcoin. If you didn't use the all flag, then you'll have to do pip install UVcoin as well, but we already got it installed. And so let's go back here and let's run our API. So we do UVcoin. Then what we have to do is we have to reference the name of our file. So this is their entry point into our application, which is our main file. So here we're going to say main. Keep in mind, if this file was named anything else, we don't have to name it main. You can name it anything else. You would just want to pass the name of whatever the file name is. Then you do colon, then you pass in the name of your Fast API instance. So we named it app, and so we'll do app, and then we'll start that. Right, and so this is saying that we started our server, perfect, and we can see the URL that our server is running on. So it's going to say http://127.0.0.1. So if you guys don't know what that address is, that means it's this machine. So whatever IP address this machine runs on, that's what this is going to be. So it's just saying, hey, we want to refer to the local host, and it's going to run on port 8000. So if you want to, you could just copy this URL, go to your web browser, paste it in here, and then see what happens. And then look at this. I'm going to zoom in for you. It says message hello world, and that's coming from our code. Right, and that's coming from this return statement right here. So this kind of verifies that everything worked perfectly. All right, so now that we've got everything up.
Okay, so key things to note here. So we study about what a REST API is, a representational state transfer, and it basically help us in managing, creating an update, and representing those resources and passing the representational state. It's the REST API is basically a collection of URIs, uniform resource identifiers, and there is some kind of format attached to it on how that API should be ready. After that, we started using this. Start off, we first create a virtual environment. Now the key is behind is if we install everything on the our global on the system, which is called as global, it might interfere with the other projects that we have built. So yeah, that's the case. So whenever we build a project, we create a virtual environment, and everything now will be installed in that particular virtual environment. So here we have created our own virtual environment for VPN. We installed fast API there. We separate the what interpreter we will be using, and important thing is we have changed the terminal to be working in this particular directory and environment. So all of this is now VN. So
Up and running and working, and you can see that
So if we install anything else, we installed here. Now once that was done, we import the fast API. As fast API, we created an app out of it, and then we start the app. And once the app has when that is done, we have to start the app. For that, we have to use the movie call, which is mentioned here. Once that is done, we are able to see the output. Yeah, we have to activate also. So that's why the three environment we have to create with v in the name, and reactivate a resource, the environment name, be an active, and we want to deactivate when deactivated. They have also created a virtual environment that will make sense. First we get divided and we can activate, and next Mac. So required packages, create products.
go to our website, we can see that we are properly getting back our message. Let's pause this video, and in the next video, we'll take a look at exactly what each line of this code actually means. Alright guys, so let's take a look at the code that we added and actually dissect what each line means. So we've got these 3 lines of code, and if you take a look at the Fast API documentation that we were on, it's going to define those 3 lines of code as a path operation. So that's the terminology it's using. It refers to this as a path operation. Now, the name itself doesn't really matter. You'll see that in other web frameworks, especially in other languages, sometimes they refer to this as a route, but they, within the documentation for Fast API, refer to it as a path operation. So you'll see me flip between those 2 terms, but they fundamentally mean the same thing. So let's actually take a look at this specific path operation, and we can really see that it's made up of 2 components. The first component is going to be the function, and the second thing is going to be the decorator. So we'll come back to the decorator in a bit. Let's take a look at this function. So this function is fundamentally no different than any other Python function. It's a plain old function. You'll see that there's this async keyword. Technically, this is optional. This keyword's only needed if you're going to be performing some sort of asynchronous task, so something that takes a certain amount of time. So things like, making an API call, things like talking to the database. If you want to do that asynchronously, you do have to pass in the async keyword, but we're not doing that right now. So what we can do is we can actually just remove that. So I'm going to delete that and just remove that. And so now, it's just a regular function, and you'll see that the code behaves exactly the same. So we have a function, we give the function a name, so the documentation just shows an arbitrary name of root. Keep in mind the name itself doesn't matter. So if I wanted to name this, get user, then that's going to be fine. It's not going to change anything. It's an arbitrary name. However, I do recommend you name your functions, your path operation functions, to be as descriptive as possible. So if you're trying to log in a user, then maybe you should call this login user, or just log in, so that it's as descriptive as possible. But keep in mind, the name that we put here does not matter. So I'll change this back to root for now. And then then within this function, you can perform any kind of logic. So if this function is meant to log in a user, it's going to have all the code for logging in a user, whatever that may be. So maybe, checking the passwords in a database to make sure that they match and to make sure that the credentials are properly accurate. And then after that, just like any other function, we can return something. So whatever we return here is going to be the data that gets sent back to the user. So if we go back to the website, go to our website and the code for any kind of logic. So if this function is meant to log in a user, it's going to have all the code for logging in a user, whatever that may be. So maybe, checking the passwords in a database to make sure that they match and to make sure that the credentials are properly accurate. And then after that, just like any other function, we can return something. So whatever we return here is going to be the data that gets sent back to the user. So if we go back to the website, go to our web server, if you take a look at this message, hello world, that's exactly what we sent. And if we change this to be whatever we want, it's going to get returned back in the same way. So here we're just returning a Python dictionary, I guess. And what happens is Fast API will automatically convert this to JSON, which is the main universal language of APIs, right? We use JSONs to send data back and forth between an API. So it converts this to JSON and it sends it back to the user. And that's why we see that on the web browser. Now, the next thing that we have is this decorator. If you're not really familiar with decorators in Python, it's okay. You don't really actually need to understand, the core concept of a decorator. Just understand that when you apply a decorator to a function, it's going to perform a little magic to this function. Because if I remove this decorator, if we just comment it out, take a look at this code. This code has nothing to do with Fast API. It's a plain old function. So how do we actually make it, act like an API? Well, we have to use this magical decorator. This decorator turns this into an actual path operation so that someone who wants to use our API can hit this endpoint. And so you just specify the @ symbol. That's what that's how we clarify that this is going to be a decorator. Then we reference our fast API instance, and then we have a couple of different options. So what we pass in is the HTTP method that the user should use. So this is a GET method, which means that we have to send a GET request to our API, but we can use plenty of different HTTP methods. And I strongly recommend you actually take a look at the different HTTP methods. If you do HTTP methods, we can select this one. This is the Mozilla page. You can see all of the different HTTP methods. So there's get, post, put, delete. So those are the main ones. There's a couple of other ones that are sometimes used, but for the most part, those are the core ones. And so here, once again, just the HTTP method. And then finally, we have the path. And so this is the root path. And so it's a little bit hard to explain the path, but it's basically the path after the specific domain name of your API. So if you take a look at our URL, our web server is hosted on this specific URL. If I go to this page, let's open up a new link, just paste it in here. So the URL and the path in this case is just slash. So that's the equivalent of just hitting enter right here or putting a slash, which doesn't change anything, right? Right? Whether there's slashes there or not, it's basically going to take you to the same URL. It's very similar to going to, google.com, right? That's going to take us to google.com. But if we go to google.com/, it's the same thing. So it's the root path. So whatever domain name our API is hosted on, whatever URL, it's just saying it's the root path. If I change this to, log in, right? That means that this path operation will only apply if the user goes to our URL and then goes to /login. So that decorator, this path right here, just references the path that we have to go to in the URL. And so if this is actually changed to, how about posts, and then, like vote, so maybe this is the URL for voting on a specific post, then we would have to go and do the same thing here. So we'd have to go to post/vote. So nothing too complicated, but those are the two pieces that make up a simple path operation. You've got the function, then you've got this decorator where you have to pass in the specific HTTP method, and then the URL you want it to go to. And I'm going to change this back to the default. And now what I want to do is, let's go ahead and make a simple change. So what I'm going to do is I'm going to change this. I'm going to change the message to be, welcome to my API. We'll save this. Go back to the root URL because we changed it to the root URL. Let's hit refresh. Notice how it still says hello world. Nothing changed. So what gives, right? Our code's changed. I saved it. Why are we not updating it so that it returns welcome to my API? Well, the problem is that anytime we make a change, we have to restart our server. So to restart our server, you hit Control-C, which is going to stop it. Then you can just hit the up arrow key so that you can find that command that you ran before and just run it again. And so now if I hit refresh, we can see that it updated. And I'm sure you're thinking, well, that's a little annoying. Every time I change my code, I have to do a Control-C and then an up arrow and then hit enter just so that I can, make sure that the server actually implements those changes. And it is a little annoying, but there is a workaround. So if we go to the documentation, you'll see that when they run UVcorn, they pass in the -- reload flag. And the -- reload flag will actually take a look at your code and monitor your code. So anytime that you change your code, it'll automatically restart your server for you. So let's try that out. I'm going to do a Control-C. I'm going to hit the up arrow, and I'm going to pass in the -- reload flag. We'll hit enter. And now what I want you to do is make some changes. So it doesn't really matter what you change. I'm just going to add a couple of exclamation points. And then I'm going to hit save. And I want you to focus on what happens down here. So if I hit save, look at that. It automatically restarted the server for me. And so now if I go back to my website or my API, hit refresh, you can see that the exclamation points are there. So moving forward in a development environment, only when we're in a development environment, we're going to pass in the -- reload flag. When we go to production, we don't need that. We're not going to be setting it up because we're not going to be changing our code in a production environment. And so I think that's a good stopping point here. In the next video, we'll just quickly review exactly what is a path operation so that we could just reinforce what we learned in this lecture. All right, guys, so let's quickly recap what we learned in the previous lecture. I want to make sure that you guys have a solid understanding of the different components of a path operation because ultimately, that's all your API is. It's just a bunch of path operations. So first things first, we have our decorator. So our decorator has the little @ symbol, and so that's what signifies it as a decorator. And then we reference our fast API instance, which we called app, And then we have our HTTP method. So in this case, this is going to match only get methods. And then we have the specific path or the URL. So this is the root URL in this case. And then below that, we've got our specific path operation function. So this function is going to contain all the logic for performing some kind of task. And it's going to return some data, and that's the data that gets returned to the user when they hit this specific path operation. So now that we have a solid understanding of how path operations work, let's see if we can create a new path operation. And let's say this one represents retrieving a bunch of social media posts from our application. So in this case, there's two things that we need. So the first thing is our function, our path operation function. So we'll say def, and then we'll give this function any name. I think since we're going to be retrieving a bunch of posts, I think a good name is going to be get_posts. But keep in mind, you can name this anything you want. Like I said, it does not impact the behavior of anything. And then we want to see, so here we would pass in all of our logic for retrieving posts, but we don't actually have an application. So I'm just going to say return. And then we'll just say, maybe, I don't know, data. And this is going to be, this is your post. But in reality, we would provide a list of posts. So let's save that. And then there's one last thing. We have to pass in our decorator like we did before to actually make this turn into a special path operation function. So we'll say at, and we reference the instance, the fast API instance. We'll do app dot, and then we have to figure out what HTTP method we want to use for this path operation. So when it comes to retrieving data, you usually use a get operation. And if you don't know which one to use, you can just go back to this page right here, and it's going to explain what each one's for. So if you select get, it's going to explain when you would use a get. If you want to use a post, it's going to explain when you should use post. But I already know that for retrieving data, it's usually a get operation. So we're going to keep it as a get method. Now for the URL, I'm going to say to retrieve posts, we want to go to the /post URL. So let's save this, and then let's see if we can retrieve that data. So if I hit refresh here, it's going to say hello world, but that's because if you take a look at this, we're at the root path, and that's going to match this specific path operation. And this path operation is on /post. So if we go to /posts, a request to our API server, it's going to actually go down the list of all of our path operations, and then it's going to find the first match. And as soon as it finds the first match, it's going to stop running your code. So if I actually change this to just the /URL, just like this one above, what do you think is going to happen? Right? They both reference the get method, and they both reference the same URL. So which one do you think is going to win? Well, let's take a look. If I do just the / again, it says hello world. So it looks like the first one won. And the reason for that is that, once again, Fast API literally just goes to the code and it looks for the first match. So there's really only two criteria in this case. What's the HTTP method? It's a get. So anytime you work in your browser is always going to send a get method by default. And then what's the URL? So the URL is the /URL. So it matches this one, and it does not continue past that. So it never runs this code. So it sends that back. Now, if I took this, copied it, and moved it to the top, what do you think is going to happen? Which one do you think is going to run? Well, let's hit refresh. Look at that. So that one ran. So the first path operation that matches is always going to be the one that runs. Simple as that. So the order does in fact matter. However, if I change this to posts and leave this at the top, right? If I hit refresh, we get hello world. So what happened was Fast API went down the list, right? And it received a request that, let me just put some comments. So the request comes in, sorry, that's not the way to comment in Python. Request comes in with a get method, and it comes in with the URL is going to be /. All right. And so these are the two things that it looks for to match. So it hits the first path operation. So this is a get, so those two match. And then it looks at the URL, which is /, but that does not match. So it skips past with this one, and then it goes to the next one. And then it checks to see if that matches. So then get matches, the URL matches, so then it returns hello world, and that's why it returned hello world. And the reason I wanted to highlight this is that the order, in fact, does matter. So you have to keep that in mind, and it can impact the way your API ultimately works. I'm going to just take this, move this to the bottom. But in this case, the order doesn't matter because they're hitting two different paths or two different URLs. Till now, we've been using our web browser to generate HTTP requests to test our API. And that's fine for now. However, once we start getting into more complex path operations and routes, so things that involve having to send a HTTP put or patch or any of the other methods and having to send data to our API, it gets very complicated because there's no way to natively do that in the browser without generating or building out a complete full front-end application. And to test an API, you shouldn't have to build an entire front-end application to do that. That would be, unmanageable, unscalable. And so there's a lot of different tools that we have that we can use to test our API. And so one of these tools is called Postman. So if you go to postman.com/downloads, you can download this app. So go ahead and just hit the download button. It's going to automatically detect what your operating system is. But this is a very simple tool. It's just a tool that allows us to construct our own HTTP request. So we get to specify the individual fields of an HTTP request. So we could specify, what is the HTTP method? What's the URL? What are the headers that we're going to apply? What's the body? What kind of data is that going to carry? Is it going to have any authorization headers? So all of these things we get to construct in a nice GUI so that we can test our API. So go ahead and download this. Now I've already got it downloaded, but once you've got it downloaded, open up the desktop application and you should see something like this, right? Everything should be relatively empty. And what we want to do is, if we want to create a new HTTP request, all we have to do is hit the plus button. And before I do that, what I'm going to do is, let's change this to dark themes. So themes, I think this looks a little bit better. Yeah, that looks a lot better. And I'm also going to zoom in for you guys. Let's make it a little bit more. There you go. Hopefully that's nice and easy for you guys to see now. So what we want to do is let's create a new HTTP request. So hit this plus button. And you can see that this provides us all of the fields that we need to actually create an HTTP request. So the first thing that we need to do is specify what's the HTTP method. So if we go back to our code, right, we only have GET requests. So whether we want to hit either one of these path operations, it's going to have to be a GET request. So we're going to leave it as GET, but you can see we have all the other, we have all of the other options. Then we have to specify the URL. So this is no different than the URL that we went to in our browser. We just copy this URL, and we actually need the HTTP. HTTP in there as well, probably. So if we actually go back to our server and see where we started it, and actually the best way to get the URL is just to stop it, start it, and then that's going to give us the URL. So we just needed the HTTP beforehand, and then we just paste that in there. Okay, and so if I leave this as the the root path, whether I include the slash, it doesn't really matter actually. I can just hit send. And you look at this, this is the result that we got back from our API server. So it says message hello world. And once again, you guys already know where that came from. And that came from this specific return statement. And so you can see that this is so much easier than using a web browser. Well, you guys may not notice how easy it is at this point, but once we get to constructing more complex path operations, you'll see that it's so much easier to use a tool like this. And keep in mind, this isn't the only tool that does this. There are plenty of other applications that also do this. This is just the one that I'm familiar with and the one that I use, but I don't want to, force any specific application down your throat. You guys can use whichever one you want. So if you already use one that you prefer, feel free to stick with it. But before we wrap up this video, let's just test out our other specific path. So this one's going to reside on /posts. We're going to try that. We'll do /posts. We'll hit send, and look at that. We got our data that says this is your post. So now we were successfully able to test both of our path operations using Postman. And moving forward for the rest of this course, we're no longer going to use the web browser. We're going to use Postman to test out our API. Till now, we've only been working with GET requests. So all of the HTTP requests we've sent to our API all have been GET requests. And so now we're going to learn about POST requests. And they're a little bit different, and I want to kind of highlight what makes POST requests different than GET requests. Now, we're going to compare the two right now, and I've drawn out a little diagram for us. So at the left side, we've got our web browser, or it could be our mobile device, depending on whatever the front end is. And on the right side, we've got our API server. So this is our fast API server. Now, with a GET request, what we do is we just send an HTTP GET request, and then we send that to our API server, and then our API server sends back some kind of data, depending on what they're trying to get. So if they're trying to get a whole bunch of posts, we send back the post. Now, with a POST request, it's going to be similar, except there's one minor difference. And that is that with a POST request, we can send data to the API server. So in this case, a lot of times what you use a POST request for is for creating things. So if I want to create a post, I would, when I say post, I mean like a social media post, not post as in POST request. But if I wanted to create a social media post, I would send an HTTP POST request, and I would include all of the data needed to create a post on my API server. So we'll send that data over to the API server, and the API server will send back whatever data it thinks it needs to send. And so in real life, if we were trying to create a post, we would include whatever data we needed for a post. So in this case, we would include what's the title of the post, what's the content of the post, what's the user of the post. We send that to the API server. The API server can then talk to whatever database to actually create the post, and then it can send back some data, something like, hey, I've successfully created the post, and then here's the final post after I create it, and then send those details. A GET request is central to the request is of how for decorator first. We'll do app dot, and instead of get, we're going to say post. So that's all it takes to convert a traditional GET request to a POST request. You just say .post. And then once again, we're going to say whatever specific URL the user should go to actually create the post. Now, I'm going to do something a little bit bad. I'm going to say the path that we want to go to is called create post. And if you've ever worked with APIs, this is kind of going against best practice, but don't worry, we'll correct this in the next lesson. Because there are certain best practices. It's not going to break our application by any means. We'll say this, and then we'll say def, and then here we'll just name our function. I'll just say create post. Like I said, the name of the function never matters.
APIs.
And then here, all we're going to do is we're going to return. We'll say message, and then we'll say successfully created posts. So let's save that, and let's go to our Postman. And so we've got already one request, so I could just change this to post. And then we have to change the URL in this case. So we'll go back and see that create post. So it's going to be at create posts. And let's hit send and let's see what happens. Look at that, message successfully created. So we have successfully sent a post request to our API. Now, one thing I like to do with Postman is that you can create multiple requests and then have them saved. So I'm going to actually change this back to just go to posts and then go to get, and then we'll keep that. And what we can do is we can just add another request. And so I'm just going to copy the URL here. I'm going to paste this, and then this is actually going to be create posts, and then this is going to be a post request. And so now we can hit a get request and then hit a post request really quickly because they're essentially, we've got them in two different windows. And let's just quickly double check that still works, that's good. And then let's double check a get post, that still works, perfect. Now that's cool and all, however, the whole idea behind a post request is to send some data to our API server. So how do we do that? Well, let's go to our post request. And what we want to do is we want to send some data in the body of the request. And to do that, within Postman, you would go to the body section right here. And then within body, what we want to do is go to raw and then select the type. And normally, when you're working with APIs, you want to use JSON. However, you can use XML and a few others. However, most people use JSON. So we'll select JSON. And then we'll do, and JSON looks it operates very similarly to a Python dictionary. So it's, curly JSON. And through that, we want to send, the whole idea behind a post request, this, the post request, that create posts, so it's going to be and let's get post from that. And what we can do is we can and so now that's cool and all. However, we want to send some data in the body of the request, and normally a few others, however, Python dictionary. So it's curly braces, and then it's going to be a whole bunch of key value pairs. So here I'll say, what's the title of my post? Well, the title of my post is going to be we'll say top beaches in Florida. And then the content of the post is going to say, check out these awesome beaches. All right, and so now, if we hit send, let's see what happens. Great, so it says successfully create a post. We successfully hit this endpoint, but in our path operation, how do we actually extract the data that we sent in the body? How do we retrieve that body data? Well, what we can do is within our path operation function, I can say, I can just assign it some variable. So what variable do we want to store that body data? You can pick any name you want. I'm just going to say this represents payload, although it could be something like body or anything else. So we'll say payload. And then what we want to do is colon. And then we want to say it's going to be of a type dict. And we want to set this equal to body. And we want to import this. So this is actually something that comes from the Fast API library. So if you do tab, if you hit tab, it's going to automatically import it, or you can select it. So you hit body and then do that, and then triple dots. And just to keep in mind, right, if you see that from Fast API params, it imported body. So what this is going to do is it's going to extract all of the fields from the body. It's going to basically convert it to a Python dictionary, and it's going to store it inside a variable named payload. Pretty simple. And all we have to do is, let's say print. Let's just print out payload. Now if we hit that post request again, look at this. Right here, we can see that it converted. keep in mind, it's going to basically convert it to a Python dictionary, and it's going to store it inside a variable named payload. Pretty simple, and all we have to do is, let's say, print. Let's just print out payload. Now if we hit that post request again, look at this. Right here, we can see that it converted it into a Python dictionary, and we extracted the title field as well as the content field. And so that's how we extract the data from the body of the payload. All right, and just to quickly recap, once again, we imported body from fastapi.param. extract the data from the to a Python dictionary. So it's curly braces, and then it's going to be a whole bunch of key value pairs. So here I'll say, what's the title of my post? Well, the title of my post is going to be we'll say top beaches in Florida. And then the content of the post is going to say, check out these awesome beaches. All right, and so now, if we hit send, let's see what happens. Great. So it says successfully create post. We successfully hit this endpoint, but in our path operation, how do we actually extract the data that we sent in the body? How do we retrieve that body data? Well, what we can do is within our path operation function, I can say, I can just assign it some variable. So what variable do we want to store that body data? You can pick any name you want. I'm just going to say this represents payload, although it could be something like body or anything else. So we'll say payload. And then what we want to do is colon. And then we want to say it's going to be of a type dict. And we want to set this equal to body. And we want to import this. So this is actually something that comes from the Fast API library. So if you do tab, if you hit tab, it's going to automatically import it, or you can select it. So you hit body and then do that and then triple dots. And just to keep in mind, right, if you see that from Fast API params, it imported body. So what this is going to do is it's going to extract all of the fields from the body. It's going to basically convert it to a Python dictionary, and it's going to store it inside a variable named payload. Pretty simple. And all we have to do is, let's say print. Let's just print out payload. Now if we hit that post request again, look at this. Right here, we can see that it converted it into a Python dictionary, and we extracted the title field as well as the content field. And so that's how we extract the data from the body of the payload. All right, and just to quickly recap, once again, we imported body from fastapi.params, and we let VS Code do it automatically for us. I always recommend letting VS Code do it for you so that you don't have to memorize and remember, you know, where in the Fast API library this property is stored. So we're taking the body, and then we're converting it into a dictionary, and then we're storing it inside a property called payload, but you can name this whatever you want. And so what we can do is we can take this data, and then we can say, let's say we're going to return back new post, and then we're just going to send the data. So we'll say title, and we can actually change this to a F string. And we'll say title. And then we can pass in payload. And you'll see that it's, we can just reference the title property, because it's just a regular Python dictionary. And we'll say that the content is going to be payload content. So let's save that, and then now let's hit send. Now look at this. We got our new post, and it said, whoops, it looks like I made a mistake. Yeah, no, actually that's correct. Title, top beaches in Florida. Content, check out these awesome beaches. So that's pretty simple, guys. I showed you guys how to not only send data in the body within a content. So let's save that. And then now let's hit send. Now look at this. We got our new post and it said, whoops, it looks like I made a mistake. Yeah, no, actually that's correct. Title, top beaches in Florida. Content, check out these awesome beaches. So that's pretty simple, guys. I showed you guys how to not only send data in the body within a Postman request, we're also able to extract that data and send it right back to the user. Now, in a real application, we would take the data and then we would normally store that data inside our database so that we can create a new post, store it in the database. And then now anytime the user tries to retrieve the post, we can fetch that data from the database. We don't have a database set up just yet. So for now, I'm just showing you guys how to extract that data and then send it back in the request. In the last lecture, we learned about how to work with post requests. We learned about how to send data in the body using Postman, as well as how to extract that data within our path operation so that we can perform some logic. And there's some issues that we're running into at the moment based off of the way we've kind of set up things. All right, and the first thing is it's kind of hard to get all of those values from the body. We have to, extract each one individually. On top of that, the client can send whatever data that it wants. And this is a big issue, right? I don't want the front end to send arbitrary data. If the user's trying to create a post, I want the title, I want the content, nothing else, right? I don't want them to send any extra data, right? And on top of that, the data itself isn't getting validated, right? So how do I ensure that the user is sending what I want, right? What if the user sends a blank title? I can't have a post with a blank title. So how can we validate that the data that the user sends is actually valid, right? And ultimately what we want to do is we want to force the user into a schema that we can expect, right? That's the term that we always use at the API, is a schema, where we want to define exactly what the data should look like so that it's almost like a contract between the front end and the back end saying, hey, the backend sends a message to the front end saying, listen, I expect my data to look like this. If you don't send me the data that looks exactly like this, I'm going to give you an error. And that's the way you want to work with APIs. You want to explicitly define what the data should look like so that the front end can send you exactly what you expected. So let's see how we can do that using Fast API. Now, what we're going to do is we're going to make use of a library that can do that. Using Fast API. Now, what we're going to do is we're going to make use of a library called Pydantic. Now, we've already got this installed because we used that all flag when we did pip install Fast API. So if you actually go back to your code and go to your lib folder, you should see Pydantic somewhere in here. And you can see that Pydantic's already installed. So we can make use of Pydantic to define what our schema should look like. So let me quickly show you how to work with Pydantic. It's really simple. But keep in mind, technically, Pydantic has nothing to do with Fast API. It's its own complete and separate library that you can use with any of your Python applications. Fast API just makes use of it so that we can define a schema. So let's import Pydantic. So we'll say from Pydantic, import base model. And so if we go down to our, our create posts path operation, ultimately what we want to do is we want to tell the front end what a post or a new post should look like. So we'll say from Pydantic, import base model. And so if we go down to our, our create posts path operation, ultimately what we want to do is we want to tell the front end what a post or a new post should look like. What data do we expect? So let's figure out what data we want for a specific post request. So two things that we want. We want a title, which is going to be, a string essentially. And then we want the content, which is the content of the post, which is going to be, some sort of string. Right? And so we expect the user to send both of those things, and then we don't really want anything else. We don't want the user to send any other piece of data. We just want these two things. And we can put in any other piece of data we want. So if we want the user to pass in something like, what is the category of the post, we can include that. We can maybe include the number of, I don't know, you can really we're just going to stick this comment right here. We're going to define a class. We'll call this class, and then we'll give it whatever name we want. It's going to represent what a post should look like. So I'm just going to call this post. And then this is going to extend base model. So this is what makes it a special pydantic model. We just extend base model. And then here we pass in the different properties for our post. And like I said, we want a title. And we also want the content. Now, what we pass here is going to be, what is this type of data? So if we go to this pydantic library, you'll see that there's the different field types. So we can set things to be a Boolean, we can set it to be an int, float, string. So all of the common Python types, list, tuple, it's all available within pydantic. So we know what ultimately what a title should look like. So what do you guys think should be the field type for the title property? Well, I think it makes sense. It should be a string, because this looks like a string. It's got some text. It probably should be a string. So let's set this to be string. And the content should be the same thing. It should also be set to string. And now what we can do is, let's take this model and go down to create posts. And instead of extracting the payload, what I'm going to do is I'm going to reference that post pydantic model, and then I'm going to save this as a variable called post. Once again, they don't have to match, but since this will represent the post, I can call this maybe new _ post or something like that, and then reference the post pydantic model. So what's going to happen is, because we pass this into our path operation, Fast API is automatically going to validate the data that it receives from the client based off of this model. So it's going to check, hey, does it have a title? If so, is it a string? If the title doesn't exist, or if it's not a string and maybe we pass an integer, then it's going to throw an error. It's also going to check for us if content's available. If it is available, it's going to make sure that it's a string. And if content's not available, or if it's not a string, it's going to throw an error. So it's doing all of the validation for us, and it's defining the schema of what it should look like for the front end. What kind of the data should the front end send to us? So we're going to remove all of this nonsense. And I'm just going to, for now, just say data, I don't know, new post for now. And now, what I'm going to do, instead of print payload, we're going to say print new _ post. So let's save this, and then I'm going to send a post request. Okay, so that up this. And then I'm going to send a post request. Okay, so that updated fine, but let's take a look at what this printed out. So take a look at what it printed out. Look at that. It automatically extracted all of that data for us. So now we can access, post.title, and we can get the title of the post. And we can also access post.content to get the content of the post. And just to prove that to you guys, we'll say post.title. So we'll save that, we'll send a request. And now look at that, look how easy it is to extract that data because it's already assigned to that new post variable, and we can just access each property based off of what the model is defined as. Now that's great and all, but let's check to see if it's actually performing all of that validation. So if I go to my Postman and I remove title, let's see what happens. I'll hit send. Look at this. Look at this. It's saying that inside the body, there's a title field and it's saying a value error, it's missing. Now we didn't tell Fast API to send this, but it automatically does the validation for us and sends back an error message. And then it sends back a status code. So this is the status code of the message. It sends a 422. We can change that later. Don't worry about that. But it's automatically performing the validation. And that's what's awesome about this. And if I add the title back, what was it? Top beaches in Florida. And instead, actually, if I change this to be a 1 or something, and I need that comma, let's see what happens. If I hit send, it looks like there's no errors. And that's because the number 1 can actually be converted into a string. So it's not going to throw an error on that, and that's perfectly fine. And that's perfectly fine, so that's not a big deal. But let's change this back. Like I said, it's going to try to convert whatever data we give it to a string. So as long as it's able to convert it to a string, it's okay, and any integer that we pass can be converted to a string. So I'm going to change this back, and I'll add top beaches in Florida. Florida. Let's see what happens if we remove the content now. If I hit send, look at that. Now it's saying the content is missing. Perfect. So our validation is working exactly how we expect it to. And then I forget what was it, something beaches, or I can't remember what it was. Now let's say that we want to assign a property that's optional, right? Like what if we wanted to make it so that the front end can either choose to send some piece of data or not send a piece of data. So let's say that we want the user to be able to
I'll go to gym and buy some things, and I'll resume in the night again. Bye bye.